Alrighty, let's go ahead and talk about multiple dispatch in Julia. For those of you that don't know, Julia is a programming language basically used mostly in data science and data visualization, and it was created to sort of have the simplicity of Python but the power and efficiency of C. Pretty big task to take on. Uh, the main paradigm of Julia is what I'm going to be talking about today, which is multiple dispatch. And I feel like the best way to kind of dive into multiple dispatch is to just go ahead and get into Julia REPL by just typing in Julia and start showing you guys what it's all about. Let's say that I want to define a function called add or concatenate, and this is going to take two arguments, a and b. And what I can do in Julia is I can define the types of this argument, and let's say that I want a to be an int and b to be an int, and the types of the functions are the arguments are basically defined by this double colon operator here. And I'll say return a plus b, and then to end the function body I'm going to type in end. Multiple dispatch basically allows us to take this function add or concat, which right now Julia tells us that it's a generic function with one method, and based on the types and the arguments that we pass it, have it return different things. So in my case, I'm going to say add or concat, so I'm going to call it the same thing, and I'm going to say if I have an element of type string and another element of type string, I want to return those two strings concatenated. And in Julia, when we're working with strings, this star here is the operation that we use for concatenation. And now we see that Julia says that add or concat is a generic function with two methods instead of one. And if I call add or concat with the numbers 1 and 2, I'm going to get the answer 3. Otherwise, if I call it with the strings 1 and 2, I'm going to get the string 12 as the answer. Looking at it right now, this seems pretty similar to method overloading or something like that in Java. So a really great question is, why would this be the main paradigm of the language, and how is this any different than method overloading in Java? And to show that, I have a little bit of a larger example, and just for time's sake, I went ahead and wrote some code here, but I'll go ahead and go through that right now. What this code is basically doing is defining an abstract type of shape, which in Java would be an interface or something like that, and then these structs of rectangle and triangle, which are subtypes denoted by this operation here, less than colon, of shape. And they each have a width and the rectangle has a width and a height, and the triangle has a height and a base. And then in this file, I'm also defining this function called area. And again, with multiple dispatch, I'm saying that area can take a generic shape, in which case it just returns the string generic. It can take a rectangle, in which case it's going to return the area of the rectangle, being the width times the height. Or it can take a triangle, in which case it's going to return the area of the triangle. So this height times base over 2. Alrighty, so let's go ahead and hop back in the Julia REPL, and we're going to say include shapes.jl to include this file. And right now we're going to see that it's going to tell us that we've included this function area, which is a generic function and has 3 methods. Very good. I can create a new rectangle object by using this syntax. And let's say that I want to give it a width of 2 and a height of 4. And then if I call area on this rectangle, I'm going to get 8. I can do the same thing for a triangle. And let's say that I want a base of 3 and, I don't know, 5. And then if I call an area on this triangle, I'm going to get the area of the triangle, which is 7.5. Alrighty, so let's put ourselves in more for like, I guess, from a contextual perspective. Let's say that I have a huge bunch of data, a bunch of objects, basically a bunch of shapes that I need to calculate the areas of. And let's say that a lot of these shapes are actually not just simple rectangles, but they're squares. What I can do is I can go ahead and create a new struct called square, make this a subtype of shape, and let's say that this just has a side, which is also a float 64, which is basically just a float. And I'm going to go ahead and say function area, which is the same function that we got from our quote-unquote package. And I'm going to say that this time it takes an argument of type square. And in case it takes an argument of type square, I wanted to just return the the area of the square, which is just like the side squared, more or less. And I'm gonna say end, and now I see that area is still a generic function with 4 methods. So I've still retained the same function area that we're using. And now if I create a new square with a side, let's say a 5, if I call area on the square, I'm gonna get 25. So if we were iterating over a list of a lot of shapes, and we had a bunch of squares, and we wanted to actually use this function, keep using this function area in those shapes, we could just define another method for area, like we did right here, and using multiple dispatch, area would be able to tell what argument it's taking and what it needed to do. Another very good use case, which this one's my favorite personally, is that we can redefine what we got from our quote-unquote package to do something else that we want. So let's say that the area for the rectangle in the package that we imported basically got the area for the rectangle, but we wanted to do something else in case that we passed a rectangle. We're going to go ahead and say function area, and we're going to say that it takes a rectangle, and I'm just going to return 1 here. I'm going to end this. And we see that it still only has 4 methods, and in this case, if we do call area with that R1 rectangle that we created earlier, we'll only get this one. So basically, the takeaway from this video is that multiple dispatch is basically a lot stronger because it allows for a lot more code reuse and more flexibility when working with externally imported packages and kind of shaping them for how your data looks and for how you personally want to use them. As opposed to in Java, if we wanted to do something like this right here, we'd either have to create our own classes and then define those, or have to convince whoever created the original package to actually edit it to make the rectangle method do this, while in Julia, it's as simple as just basically redefining this method for the area function using multiple dispatch. And yeah, that's basically all of it. Hope you enjoyed it.